Hey, I'm Max, and recently I made a tutorial on how to make an enemy eating game and how to code a realistic AI for it, and that was to turn it into a sort of fake multiplayer game. But in my original video I used a neural network, and many people in the comments asked very nicely for me to make a tutorial on how to make the neural network. And I just couldn't say no to such nice comments. A little disclaimer before I start, I am not very experienced and actually don't know that much about neural networks. If I realize I made a mistake, I'll leave a comment so you can see the corrections. But today I'll be showing the most simple form you can make a neural network pretty much, so it should be okay. In this first part, I'll be making the general neural network part, and in the second part, I'll show how to save and load the data, as well as show 2 examples of applying this network to a game. So let's get started. First, create a new script and call it neural network. Now open up your neural network script. We actually don't need the neural network to be a mono behavior because we will put it inside our AI script. So I will just remove the mono behavior and the 2 functions. In our neural network class, we could simply put arrays of weights and biases, which I will explain later. And this is if you want every node to connect with every other node, which is how basic neural networks are made. However, I've found that for games, it's better to have control over which neuron is connected to which other neuron, because some things being linked just don't make sense, like the player's HP and the player's speed. Why would they be linked? There's no point. And so I think it's easier to make your own connections instead of connecting everything. Technically, you could still connect everything and they would end up learning that some connections are bad, and the weights would end up being 0. But it's just easier and way faster to train afterwards if you control the connections. So first, public class connection, which will be a connection. So this is very advanced stuff, okay? Each connection will have its own weight, which is basically a multiplication of a connection between 2 nodes. So for example, the direction to the closest enemy in X and the movement of the player in X will have a high weight because they're important to each other. But the distance to the enemy in X and the movement of the player in Y are not going to have high weights because they don't matter much for each other. So public double weight. Then we need to create a node which will have a list of connections that are pretty much going into the node. So public class node, public int ID, so we need an ID for the node. We also need the public double bias, which is going to be an addition or subtraction done to the value on each node. So this is useful because a node will add the output times the weight of every node connected to it. So if there is 5 nodes connected to this node right here, and each 5 of them have a value around 1, well, when you add them all, you're going to have a value around 5. So if you keep that like this, every layer is going to end up growing and growing in size, and you don't really want that, so a bias is going to help reduce this or increase this. If the weights are very small, like 0.01, then a bias is going to end up fixing the range that might be too low or too high. Then you want a public array of connections, so connection array, connections, and to be more clear, these are the incoming connections, so connections going into the node, not out of it. Then we want a public double output, which will save the output of this node. In the connection, we also want to add a public int from ID to save the ID of the node that this connection is from. So for example, all of these connections in connections, the from ID of these connections will show which one it's connected to. So this node, connection, from ID, will lead to the other node. Then we can generate our constructors. For the node constructor, we'll actually make it ourselves because it will be a little bit different. So public node int ID for the ID of the node. Then we want the double bias. Then for the connections, we won't actually input connections, but rather ints for the connections IDs. So this is going to be the from IDs right here, and we will create those connections in the constructor, and the output, we don't need it. So first this.id equals ID, this.bias equals bias. Then for the connections, we'll actually do a for loop for the amount that we have, just like this. And then we'll simply add to in connections At the position I, we will set it to a new connection with a weight by default of 1 and the from ID being the connection IDs at the position I. So we will simply create a bunch of connections with weight 1 to the IDs that we specify in the constructor. And finally, just to be safe, it should still be 0 by default, but it's better to put output equals 0. Okay, so while I was editing this video, I realized that I forgot to show a fix that I made later. So I think I'll just record this now and put it into the video so you can see the fix immediately, rather than fix it in the next part where it's going to be confusing. So here, before we add the in connections and set it to a new connection, we first have to initiate our array size, because in C# you have to set the size before setting anything into the array. So here you have to set a new connection array with the length of the connection nodes, and then you can set them. Okay, so for the rest of the video you won't see this line here, but keep in mind you have to keep it. Okay, so now we have our connections, we have our nodes, which include a list of connections, and now we need a list of nodes, which is called a layer. So public class layer, and inside we can simply put an array of nodes called nodes and a constructor public layer array of nodes equals to nodes. So this is pretty simple. So now we have our connections, our nodes with arrays of connections, our layers with arrays of nodes, and now you probably guessed it, in the network we'll have arrays of layers. Okay, so public layer array layers. We also need a public int array for the layer sizes, and this is going to be to initialize them. And we also need a public int node count for the IDs. Then in the constructor we can do public neural network, and we can simply input the int layer sizes. Damn, my Visual Studio is freaking out. Then we can do this dot layer sizes equals to layer sizes, and we can simply create our array of layers and then connect them however we want. So to create the array we can simply do layers equals to new layer array with the size of the layer sizes. So if we input as layer sizes, let's say 3, 3, 2, then it's going to have a size of 3 and create an array of 3 layers. Now by default I will connect all of the nodes together, meaning that this whole connection system will be kind of pointless, but after that I'm going to show how specifically you can select which one you connect with each other to make the training a lot faster and the AIs a lot better. So to connect them all, I'll simply do public void connect all. In here I'll do a for int I equals 0, I is smaller than layers.length, I++. And for each I will create an array of nodes, so node array nodes equals to new node array of layer sizes I. So for this layer, how many nodes does it have? So this is the layer size. So let's say, like I said earlier, 3, 3, 2. So the first one is going to be an array of 3 nodes, then 3, then 2, right? Then we want to loop for all of those nodes. N is smaller than nodes.length, n++. And for each one of those nodes, we want to create the connections. So int connections, if I is smaller than or equal to 0, so basically equal to 0 because it can be less, but I always do this just in case, it's a bad habit. So if this is the first layer, there is no connections because those are incoming connections. So the first layer has no incoming connections, it's the first one. So it's just connections equals to new int 0. If it's not the first one, then we need to connect with the previous layer, so connections equals to new int layer sizes I. And here it's important to do -1 because we want to connect with the previous layer. So we will connect this layer with the previous layer, and we will do this until the end so they're all connected. Then we need to fill these connections, so we'll do for int k equals 0, k is smaller than layer sizes I -1, so again the previous layer, k++. So we will loop all of the nodes in the previous layer and we can simply set our connections to that. So node, the connect node, so the node it will connect to equals to layers I-1 dot nodes, and you can see we cannot go get our nodes because it's not public, so public nodes, and now we can do dot nodes, and we get the K1, and then we can simply do connections at K equals to that connect node dot ID. So we simply have to save the ID, remember, because when we create them, we use the IDs and create the connections with that. If you want to do it on one line, you can simply do this as well. I think it's less readable, but it's the same. Then we go down below the else, and here our connections array should be filled. So we will do node equals to new node at the node count, which we will then do ++ 0, and then the connections. Or if you think that's confusing, you can also put the node ++ under. Then we simply have to set our nodes at the position n to that node we just created with those connections we just created. And then after the loop of nodes, we simply have to set our layers at position I equals to a new layer with the nodes we just created. So basically, we loop through all of the layers, then we create the array of nodes for each layers, and then we loop through all of the nodes to fill our nodes with the connections, and then we loop through all of the previous layers to fill our connections with the previous node. So then we have our connections set, so we create our nodes and add them to the list, and then once our loop of nodes is done, our nodes array is completed, so we set them in the layers and we do the next layer. So this is a loop inside a loop inside a loop, but you basically just fill everything with the previous layer. And of course, don't forget in the neural network constructor to call connectAll. Okay, so pretty much everything is done now. So as you can see, it's not extremely complicated. It's just a little confusing sometimes because there's a lot of things. There's a lot of structures and a lot of class and a lot of loops. Now the only thing we have to do is do the calculations. So first of all, in the layer class, I'll add a public void calculate outputs from input with the double array inputs. So this will be the inputs that we put into the network. So things like the distance to the closest enemy, the mass of the player, the mass of the enemy. And then the network will use these inputs to create outputs, which will be, for example, where the player should go, if he should use a spell or not, things like that. So to calculate outputs from input, it's pretty easy. You just loop through all of your nodes. So n equals 0, n is smaller than nodes.length, and n++. Then you simply have to add the bias of the node. So double weighted input equals to inputs n plus nodes n dot bias. So of course the size of the inputs has to be the same of the size of the first layer because we loop through the nodes and get the inputs. So if there are any more inputs, they will be ignored, and if there are not enough inputs, then you will have an error. Once we have our weighted input, now this is the hard part that honestly I don't completely get either, but you need to activate your input before setting it as output. Now what does activate mean? Honestly, I'm not 100% sure, so this is why I feel kind of bad about doing this tutorial, but it works, so you know, you might not get everything explained perfectly, but it works. So as far as I understand, the point of this activation is to set the scale of your values. Since you add every value from the previous nodes to the next node, if you have, for example, value 1, 1.5, 0.8, then you add them, you get like 3. Then you add those 3 and then a 4 and then a 2, and then you get a huge numbers. And also different values will have different scales. For example, if I get the HP of the player, it might be from 0 to 10. But if I get the distance in X to the nearest enemy, it might be from -1000 to +1000. So how does the network deal with such different range of values? And also how does it add everything without ever going to huge numbers? I think this is what the activation function does. So in our case, I think our game is so simple we could use pretty much any activation function, but the most classical one used in neural networks is this one. So I'll just do double f, which is the function, or you can call it activate, and then double weighted input. And to activate it, we simply pass it through a function and return the value. So return 1 over parentheses 1 plus mathf.exp minus weighted input. Just like that, that should be good. And you have to cast it to a float, just like that. So this will, I believe, scale your values from like 0 to 1. So even if you have a -5 or a +15, it will be scaled from 0 to 1. Then you can simply set your nodes n.output equal to activate your weighted input. So take the input, add the bias, then activate it, which is to make it on a good scale, and set this as output. Pretty simple. Now we also need another function to calculate outputs from the outputs of the connections that we have. So in this case, this is for the first layer that has no connections. Now for layers that have connections, we will do public void calculate outputs. And as a parameter, we will pass the whole neural network so our layers can check the connections and then get those nodes and get their outputs. So pass the network as parameter, and then we can simply loop through all of the nodes in the layer like this. Then we get our double weighted input, just like before, equals to nodes n dot bias. So we will start by adding the bias. Instead of starting at 0, we start at the bias, so basically add it. And then we will add all of the connections times their weights. So for int I equals 0, I is smaller than nodes n dot connections in connections dot length I plus plus. So for each of the connections on that node, we will get the input node, which is the node that we're connected to, equals to network. And actually, now that I realize it, in my code I did something like look for a node with that ID, but it's probably a lot more simple to just here, instead of having from ID, we can simply do node from, and here we can do node from, and from equals from, and here we can have a node of connection nodes, and simply change this right here. And when we create the node with the connections, instead of having a list of int, we can do a list of node, and we can simply remove the .id right here and do a new node. Then we already know our input node from the connection, so we can just do weighted input plus equal nodes n dot in connections at the position I dot from dot output. So we get the output of the node that we're connected to as input, and we do times the weight. So we'll simply do that connection dot weight. So this way it's a lot simpler. We simply add the output of the from node times the weight of the connection. So sorry I went and changed things like this. I guess I should have thought of this before starting the video, but just change here node node, and here an array of node, and in the connect all here we have an array of node, we have a new node, and here equals to connect node, and that should be fine. So here's the whole code in case I missed something and I forgot to show something. There you go. I hate when I follow tutorials and I miss something and they don't show it. So I think I showed everything, but here it is just in case. Okay, so now we have our weighted input all done. So we can do just like above, nodes n dot output equals to activate weighted input. So now all of our outputs calculations should be ready. So in our neural network, we simply have to add a public double array calculate outputs, or get outputs rather, with our double inputs. Then for the first layer, so layers 0, we will calculate outputs from input and put my inputs right here. So first layer, we give the inputs and it will calculate with this using this function. And then for all of the other layers, so for int I, for all of the other layers, I will simply use the other function to calculate from the previous one. So layers I dot calculate outputs, and we need to pass as a parameter the network, which is simply this, because this function is in the network. So this will calculate the output from the output of the previous layer and set the output of this layer, and then this layer will be used by the next layer, and so on until the last one. Hello, this is Max from the future, actually the next day. I've been trying for hours and hours to train this network, to show a little bit how to train it and how it works in games, and nothing has been working, and I finally found the issue. Here I put I equals 0, which means it recalculated the input layer with itself, which is obviously not good. So I just had to put a 1 instead of a 0 right here, and it looks like that fixed everything. So it kind of sucks that I spent hours just because of a 1 and a 0, but I mean, that's what programming is all about. So there you go, don't do the same mistake as me, I equals 1, because here you already calculate 0. So you want to start at 1. And then we simply have to return the layers at position layers dot length -1, so the last one. And to return the layers as double, we can add a public double get outputs, which will simply create a double outputs for the length of the nodes, and then simply loop through all of the nodes, just like this. And for each one of them, we'll put them in the array. So outputs n equals to nodes n dot output. So just put all of the outputs of the nodes on that layer in an array and return it. Then we can do dot get outputs, and just like that, we calculate the output from input on the first layer, then calculate from the previous layer on all other layers, and then return the outputs of the last layer. And just like that, we have all of the code we need to start using our neural network. Now we just need the code to make our AI use it in game. However, this video is getting very long already, so I think I'll do the next part in the other video. However, feel free to try to use this yourself to make your own AI first. Maybe you'll get some good ideas, and then I'll show how I use it with my own inputs and outputs. So stay tuned for the next video if you want to see how I use it to make these smart AIs.